Hello and welcome to today's webinar on MPPT Disconnect RS. Our speaker today is Jason Andrade. He's a sales application engineer for Schneider Electric Solar.
So as you all know, Schneider Electric has a complete platform. The Conext XW Pro is really the heart, the inverter that's really going to power the whole system and really give us the bang. Along with this, we have a couple charge controllers, the Conext MPPT60 and the Conext MPPT80. These two charge controllers are going to be instrumental in working with the Disconnect RS and are what are going to allow us to meet the guidelines and meet NEC 2017, the rapid shutdown, and that's why we're here today. So one of the things that we needed to achieve in NEC 2017 was rapid shutdown. Now, if you guys are familiar with this was that the array had to shut off within a 1 foot boundary and have no transmission down to the charge controllers, as well as it had to cease power production at the array. We've achieved this by working with the Tigo TS4F series. There's a few different modules that will work in that range, but we focused on working with the Tigo. Primarily, they have a great track record and a very ease of installation. This is going to be achieved by using power line communication, PLC. This is going to allow not having to run external wires up to another transmitter on the rooftop, but it's going to keep it a little bit more seamless with installation just by adding the module underneath the array. One of the other features that we're going to also gain with the Disconnect RS is the ability to have arc fault detection with our charge controllers. Both the MPPT60 and the MPPT80 will be able to sense when there's an arc fault projected out by the Disconnect RS. So again, it is compatible both with the 80 and the 60. One of the other features that we'd like to highlight with the Disconnect is it's going to allow us to give a two-leg disconnect meeting NEC 2017. And in that, what we mean is you're going to be able to break both the positive and the negative when you open the disconnect switch. So that way it's safe to work on all the hardware. If in case there is a fault, we're not going to get any backfeeding through the negative. In the Disconnect RS, because you have to remember, it's kind of a dual function. It's going to initiate and kind of decipher when there's a rapid shutdown initiated, but it also is going to serve the simple disconnect sourcing that's going to replace our existing 600 volt disconnect. Very easy to install. You have side mounts or side installations for the conduit are coming up from the bottom, or a side penetration as well. So it's very flexible. One thing to note is it is NEMA 1 and will need to be installed inside next to the charge controller. When we look at 690.12 here in this illustration, we can see that the Tigo modules are allowing with the keep alive signal power transmission down to the Disconnect RS. The RS initiator typically would be mounted on the exterior of the building. If you wanted to have one interior in case there was a secondary need to have a rapid shutdown, that you are able to add more than one initiator as they're parallel, but it really only requires one for the fire code. As the RS initiator is activated, as it's turned on, it kills the keep alive signal and ceases to transmit power both to the disconnect, and then it will also initiate a hibernate command to the charge controller, as well as put the inverter into an off state until you clear the problem, turn the initiator back on, and then reboot the system. So again, with when the initiator is activated, we are dropping below the required 30 volts within 30 seconds at the array. And then also to note, the charge controller will also, because of the bleed off capacitors, will drop down underneath that voltage if the initiator is activated as well, and put the inverters in the off state. Okay, so our current solution, if you're familiar with the Schneider products, is we've always required a DC disconnect to be installed in front of the MPPT80. Currently, what you're seeing there is our 600 volt knife switch. And this would be the disconnect that would be in line with the PV to shut off the PV sourcing power. So by adding the Disconnect RS, going to the next slide, you're going to see the upgraded solution. We're really only going to be adding about 3 components to the mix here. So what you can see here is within the array, we've added the Tigo TS4s, the fire shutdown module. We added the RSD initiator to the exterior of the building. And now we also have the MPPT Disconnect RS. So just with 3 simple parts, and also by removing one, we've been able to maintain pretty good cost control, but also added the arc fault and rapid shutdown compliance to this system. So looking at design configurations, one of the nice things about the Disconnect RS, because it's a dual channel, it will work with MPPT80s up to 2 charge controllers. So you're kind of getting a 2-for-1 on the design. This is going to allow you to do systems up to 8 to 10 kW with one Disconnect RS. Now you can use it with just one MPPT80 as well, with no issues. You'll just have an available channel, or if you're running 2 strings of 8 per se, you could isolate those channels and parallel them on the output of it to have kind of an advanced diagnostic if need be for the arc fault protection. But jumping to the MPPT60 because we have a 32 amp limitation per the string, we are at a 1-to-1 ratio with the MPPT60 for the RS disconnect. When doing that, we'll jump into another slide. There is, going to be a max system size for about 2 to 4 kW with a 1-to-1 ratio. One of the things we wanted to talk about is compatible Tigo modules. We're going to be compatible with the TS4F, the TS4AF, and the RF. I believe that they've moved away from the 4F. I need to get some validation on that. I think they're currently the TS4AF is their primary module that they're pushing at this point in time. If you guys are familiar with the Tigo, it's a very simple installation. They have a tang that I would call it that will allow it to clip to the back of the module frame so that you can wire these to the module before even handing them up, which is allowing for the simplified installation of these modules. So an example system adding the Disconnect RS, we have our standard modules with our Tigos. We're going to use, again, that PLC communication. So there is no added wiring needed to initiate that with the Keepo Live being in the Disconnect RS. We can see that the wiring from the initiator is going to go back to the Disconnect RS to signal the rapid shutdown. We're also going to need to include the ZAN bus. Now, one thing to note is this, to utilize the arc fault and the rapid shutdown feature to feed into the inverter and the charge controller, you will need to have this in the ZAN bus network. That's what's allowing this to properly communicate with the rest of the system to meet all the NEC 2017 guidelines. Other thing to note is that the Disconnect RS does need battery voltage. This is for the electronics for the Tigo and for the rapid shutdown module that's inside of there. So there's really only about 2 other things that are going to be necessary from your standard disconnect to make this all work. Now, again, we can use this in bigger systems. We're able to parallel the Disconnect RSs. There's absolutely no issue with that. The only thing that we need to note that changes with these larger systems is that you're going to need to parallel the initiator signal so that it actually puts both disconnects into the shutdown mode. They will not send the signal to go into a rapid shutdown through the ZAN bus. That can only be communicated through the RS initiator switch. So that we need to note that when you're doing a large system like this, that the initiator does need to be fed to all Disconnect RSs, but while the rest of the system still maintains the same. So some of the considerations that we need to talk about when wiring this is the 32 amp limitation, or let's just say the 32 amp requirement, not necessarily a limitation. For each branch that's running through there, when we look at the diagram on the left-hand side, what we'll be doing is we're able to run effectively with most modules out there currently 2 strings through a branch. So you have the ability, if it's just a single MPPT80 to, if you had strings of 8, you can parallel those feeds to allow for a future charge controller and run them through one channel. But if you'd opt to like to isolate those or spread them out across the 2, it does give you the ability to monitor both channels for arc fault. And as we grow the system into a quad or a dual MPPT80 with 4 strings, you're able to just effectively parallel both of the dual strings, run them through the channels, and then feed out to associated charge controllers after that. One thing to note on the right-hand picture with the MPPT6150, when we have a 6150 that's completely maxed out with 4 strings going to a single charge controller, there will be provided jumpers for the output connection going to the charge controller. And I'll illustrate these in a later picture how I use them on my system. Basically, they're just jumpers that are going to install in the DIN rail that's going to combine the output to feed to the charge controller. Pretty straightforward paralleling on the output. So this is just a little bit more in-depth diagram of hooking a 6150 into the RS disconnect. You can see that we basically have the DIN rail input where you will parallel the two channels on the front side into each channel, and then going through and then also again paralleling the output out to the charge controller. Something to note is that there is 4 more DIN rail connections in there, 2 of them being for your battery connections off your DC bus that will be feeding your 48 volt or 24 volt input into the unit for the power requirements, and then also the positive and negative that you'll see, which are basically, they're not really a positive or negative, they're just a digital signal coming in from the initiator to the RSD to show that we've gone into initiation mode. So as we get into the quad setup, you can see again, this is the same installation, just instead of running to a single unit or paralleling, we're just taking both of the output feeds to either a charge controller, and we have a maxed out disconnect RS there. Something to note, as we've looked at different ways of combining these, we have branch couplers, if you guys are familiar with those. You can also use a DC combiner. Midnight makes one that they actually have a white paper showing that you can separate the comb to run the multiple channels. So we kind of have some other solutions that we can talk about of how to combine these and feed them back. One thing to note that's a little different than what we've done before, because we have to observe the 32 amp limitation. In certain situations, let's say if we have a maxed out 6150, we will potentially be running 2 positives and 2 negatives back from the combiner to observe the 32 amp limitation going through the switch before we parallel them out. So when we talk about paralleling the initiator signal, all we're doing is feeding it to both disconnect RSs. One of the things that I want to highlight here is that this can be done inside the first disconnect RS, but we're not going to be seriesing this, running it, in one disconnect RS and out to the other. We need to take both of the feeds from the input and the output and continue it on more of a parallel style. So that's one thing that we need to make clear of how to properly splice these. If you guys have any questions, you can email me and I can clarify that a little bit more if that's not making sense. So one of the great features that we have with the Schneider products is the gateway. The gateway is the view to your system. And with the GUI interface, we're able to actually see on the device list, we're able to see all of the devices that we're running on our system and their state. So in an operating state, everything will be running in an online fashion. And what's nice about this is it's the ease of configurability, in my opinion. Being able to click on each device and configure it, see its status, what the power outputs or what's going on with each device is really an instrumental feature for installers. But as you can see right now, this is my woodshop system. And in the gateway view currently, this is just the system up and running. And so what I wanted to show you is that as we flip the initiator switch, which we'll do right now, to the next, this is the rapid shutdown state. You can see here that all of the devices, as far as the inverters, the charge controllers, and the SCP controller, all the devices that require ZAN bus power to be online have all gone into a shutdown state. The only things that are going to remain operable are things that are direct connected to the batteries. We can see the Batmon, as it's still connected to the battery power, is still kept alive so that we can see the status of that. And also the disconnect RS, as it's hooked to the DC bus, is in the on state. So it shows that all of these systems in a rapid shutdown will go completely inert to keep the system safe for firefighters or first responders. So some of the examples of how we'd actually install paralleling coming into the disconnect RS is, you can see that a lot of the ways that I've done this in the past have been the Midnight Combiner or Solidec. Solidec actually sells a kit for a paralleling, doing 2 strings and then necking it down to 1. That's a pretty standard approach for installers. And then the other one would be purchasing the MPPT6, and then actually their white paper says that you can cut the bus bar and isolate it down into 2 different channels. So in this situation where they show three strings coming out, we would just simply cut the bus bar down and make that into 2 strings, and then paralleling the output is definitely an okay way to do this. I'm sure you guys are also going to come up with some interesting ways also that we're going to be able to do this in the future. So what I wanted to show you guys here is this is the inside or the guts of the disconnect RS, as well as the paralleling DIN rail. Something to note in the left-hand picture, what you can see there is we have this Sensata arc fault module that's watching both channels of the positives coming through, looking for an arc fault. That is what's going to be able to shut down the system if you have anything going on, as far as loose connections or a problem with the array itself other than rapid shutdown. You can also see in there the Tigo Keep Alive signal generator, and as well the power control board that's bringing in the DC power to power up all the devices. On the right-hand side of it, you can see what is on my system running the maxed out MPPT60 150. On the right-hand side of that, where we see the PV output, you can see the tan jumpers. Those will come in a bag. You only install those if you're needing to parallel the output of that. And they're just a push-in connection, which is going to allow you to bridge both those output channels. So it's a pretty easy way, in my opinion, to bridge those. So for those of you not familiar with the Tigo, this is an image of the Tigo TS4F. As you can see, the tangs that grab the panel, very fast and easy to attach this. Something that, again, that you guys can have your ground guy pretty much pre-wiring these modules and handing them up ready to go, which keeps it very, very much like installing a standard module. You're not attaching these to an array, which I've done quite a bit of that in the past. That's kind of a slow process to do your wire management. One of the things that's going to be very handy with using the Tigo is that you're handing this up as pretty much a standard module, and you're setting the module, hooking it up as you would just a standard string array. So there's no real added steps up on the roof, which should make this pretty easy to do. So one of the things here we're looking at is the normal operation of the Disconnect RS is, you can see in the left-hand picture, is you can see the green light that's on there. That'll be blinking. When that light's blinking, that just means that it's operating and it's communicating with the Tigo signal generator, and everything is great. In the situation that you do have an arc fault, you can see that there's a red light illuminated. The arc fault will activate. The charge controller will go then into a hibernate mode. And it's really up to the installer to diagnose, whether there's a loose connection, an issue with the array. Once they've done that and validated that everything is safe, they can simply hit the AFD reset button, which will then clear that command, and the charge controller will just come back online. If you have your homeowners go out and continually push that AFD button because of a nuisance trip, I have not seen any nuisance trips on mine. You need to really observe whether there's an issue going on with the array or what's triggering that AFD. Okay, so what I want to show you guys here is what actually happens when a rapid shutdown is activated. You instantly see the status light went out. The RSD red illuminator kicked on to show that the system is in a rapid shutdown. If you note that my inverters currently that were on there with these pictures are my XW legacy models. What we would see in those is they would flash off for about 5 seconds and go inert. They would completely go into a safe mode, and they would have to then be power cycled once you turn the initiator back on to bring the system back online. I just got my pros installed this weekend, and one of the first things I want to do was see the comparison between the legacy models and the XW Pros. And one nice thing about that is that the off light will actually stay illuminated. And once you have the rapid shutdown initiator turned back to on, you're simply able to hit the power button on the inverter and reboot the system, and it'll come right back online. At this time, you are still having to power cycle the charge controllers to reset that command to bring them out of hibernate, but a quick power cycle of the DC breakers and the system is completely operable again. So some of my other considerations I'd like you guys to think about is the initiator on the left is our standard initiator that we sell. This would be mounted on the exterior of the building, and it does need to be accessibly located probably by your main electrical panel, I believe is what the code is. Something else, I would try to consider is really, are there going to be little kids by here? They like red buttons. If somebody comes by and flips this switch and rotates it, one of the things to think about is you're going to have a nuisance trip for your customer. So there are other switches that you can purchase that can add another layer of security or not so easy to touch that would make it more similar to a fire alarm. If you reach out to me and you want to look at another switch because of those types of situations, they are readily available. You can reach out to us and we can kind of just double check to make sure that you're picking the right one. And that way you can really have a smooth installation with your customer. So the technical specifications and actually a lot of the data that I've covered here today is all available on our website. A lot of this I've kind of gone over and tried to explain, but you can go to the website for the Disconnect RS. You can review it. And also, if you come up with more questions, feel free to email me. This is a pretty easy product to work with. But again, one of the main things that we really want to iterate is that 32 amp pass-through consideration. We have all of our minimum and maximum wire sizes there for you to refer on for your installation, as far as any documentation that would be needed for your AHJ. Real good, again, key things to note, this is NEMA 1. It does need to be installed indoor. Those of you that are familiar with our 600 volt knife switch from the past, I saw a lot of people actually install those on the exterior of the building. Although we are using this as a replacement, this will need to be installed inside. So you can see that as well. It does meet all the regulatory requirements for UL 1741 to meet our NEC, and should be good to go. Another thing, again, we were talking about the configurations, different configurations for the Disconnect RS. And it's, in my mind, it's pretty easy. The 6150 is always going to be a 1-to-1 ratio. If you're maxing out that charge controller, the 8600 is pretty much a 2-to-1, but you can always refer back to this configuration guide on our website to really help you as you start your first systems with this. And again, the RS initiator switch is always only need one for every installation, unless you're going to need multiple locations that you want to be able to do a rapid shutdown initiation. One thing to jump back on is, because the Disconnect RS, it's a disconnect. When you turn the disconnect off, it's not going to activate a rapid shutdown. And in my mind, that's kind of key. I mean, there's times where you're servicing your charge controllers, you might need to go in and tighten your wires. That doesn't mean you necessarily want to put the whole system into a rapid shutdown. So they are two distinct features. It will turn off to keep a live signal up to the Tigos, shutting the power off in the same fashion, but it doesn't have the same bleed off to meet the same requirements as the NEC 2017. So, you need to remember that to actually do the RSD initiation, you have to have the initiator switch to meet that guideline. All right, there's my information, jason.andrade@se.com. That's my email address. You guys can feel free to reach out to me. Have a great and safe week.